Welcome to today's Explainer. We're taking a trip to the absolute edge of our planetary neighborhood to check out Neptune. Now, formally, it's the most distant planet in our solar system, but I really want you to think of Neptune as something more than just a freezing world billions of miles away. It's kind of the ultimate cosmic mystery, a place that literally challenged our understanding of physics, hid from our telescopes, and honestly still surprises us today. So, we're going to break down exactly what makes this invisible giant so incredibly fascinating.
So let's kick things off with a bit of a riddle. How exactly do you discover a planet you can't even see? I mean, Neptune is the only planet in our solar system that is entirely invisible to the naked eye. You can't just step outside on a clear night, look up, and spot it. So, how did we ever know it was out there? Well, the answer is basically a 19th century astronomical detective story. The French astronomer François Arago hit the nail on the head when he said Neptune was found with the point of his pen. Back in the 1840s, scientists were tracking Uranus, and they noticed something weird. It wasn't moving the way it was supposed to. Its orbit was kind of wobbling. Two brilliant mathematicians, Urbain Le Verrier and John Couch Adams, independently figured out that this wobble had to be caused by the gravitational pull of some undiscovered world further out in the dark. They didn't rely on some giant glass lens to find Neptune, they literally just did an intense amount of math. And get this, Galileo actually saw Neptune way back in 1612, but he totally misidentified it as just another background star. Fast forward to 1846, Le Verrier finishes crunching the numbers for the exact coordinates of this mystery planet, and he sends a letter over to Johann Galle at the Berlin Observatory. On September 23rd, Galle points his telescope exactly where the math told him to look, and on his very first night, boom, he finds Neptune just one single degree away from the prediction. That is an absolute triumph for science.
All right, Section 1, Anatomy of an Ice Giant.
For well over a century, Neptune was really just a fuzzy dot in our telescopes. That is, until Voyager 2 flew by in 1989 and completely changed the game with this classic deep blue portrait. When you think about Neptune, you really have to wrap your head around where it sits in space. It's 2.8 billion miles away from Earth. That is so unfathomably far that sunlight takes roughly 4 entire hours just to travel there. High noon on Neptune essentially looks and feels like a dim twilight back here on Earth.
Now, to understand that gorgeous blue color, we need to talk about its atmosphere. It's mostly molecular hydrogen, about 80% along with 19% helium. But the secret sauce is that tiny 1.5% trace of methane. Methane is basically a filter. It eats up the red wavelengths of sunlight and bounces the blue light right back out into space. But here's the catch. Uranus has roughly the same amount of methane, yet Neptune is a much more vibrant, saturated blue. So scientists actually believe there's still some mysterious, unidentified element swimming around in Neptune's atmosphere making it pop like that.
And that brings us to a really crucial distinction. Neptune is an ice giant. That's a fundamentally different beast from a gas giant like Jupiter or Saturn. If you dive beneath those blue clouds, 80% or more of Neptune's mass is this super hot, incredibly dense fluid slush of water, methane, and ammonia. It's all locked under unimaginable pressure, swirling over a solid, Earth-sized rocky core. It is literally the densest of all the giant planets we have.
Moving on to Section 2, supersonic winds and storms. 1,200 miles per hour. Let that sink in for a second. That is the supersonic speed of the winds whipping across Neptune. Despite being so unbelievably far from the sun and getting almost zero solar energy to actually drive weather systems, Neptune somehow pulls off having the fastest winds in the entire solar system. To put that into a terrifying perspective for us Earthlings, those winds are about 9 times stronger than the absolute worst, most destructive hurricanes we have ever recorded.
Naturally, winds that extreme are going to generate some monster storms. Back in '89, Voyager 2 spotted the Great Dark Spot. It was this massive, oval-shaped storm that behaved a lot like Jupiter's famous Great Red Spot. It was so huge you could comfortably drop the entire Earth right inside of it. But here's the crazy part. When we checked back a few years later using the Hubble Space Telescope, the Great Dark Spot had just completely vanished. Just poof, gone. And new spots were popping up elsewhere. It just proves how incredibly violent and dynamic this atmosphere really is.
Section 3, Clumpy Rings and Cryovolcanoes.
Stepping away from the stormy surface for a minute, the actual space around Neptune is just as weird. Yes, Neptune has rings, 6 of them to be exact. They're super faint, so for a long time, astronomers only knew they were there because background stars would seemingly blink out for a second as the rings passed in front of them and blocked the starlight.
But the really bizarre thing about Neptune's rings, especially the outermost Adam's ring, is that the material isn't smooth. The dust and ice form these distinct, clumpy arcs that all orbit the planet together like a convoy.
Orbiting right amidst those clumpy rings are Neptune's moons. Right now, we know of 16 moons in the Neptunian system, but while 15 of them are definitely interesting in their own right, we really need to focus on the massive, totally bizarre outlier of the group.
I'm talking about Triton. Triton was discovered just 17 days after Neptune itself, and man, it is a cosmic weirdo. For starters, it orbits backward. It has a retrograde orbit, going in the complete opposite direction of Neptune's rotation. That's a huge red flag for astronomers, because it tells us Triton probably didn't form alongside Neptune. It's way more likely that it's a dwarf planet from the Kuiper Belt that just got violently hijacked by Neptune's gravity. Oh, and it has active cryovolcanoes, literally shooting icy plumes miles into space, which actively resurfaces its own south pole. Because Triton is coated in this complex crust of nitrogen and water ice, it acts almost like a giant mirror. It reflects something like 70% of the sunlight that hits it, making it one of the absolute brightest objects in our solar system. It is this frozen, geologically wild wonderland, and scientists are just itching to get a closer look.
Which brings us to Section 4, the key to exoplanets.
So, why are we still so obsessed with Neptune today? Well, in 2022, the James Webb Space Telescope took a look, and wow, by viewing Neptune in the infrared spectrum, JWST peered right through the glare. It revealed these glowing, high-altitude methane ice clouds and gave us our clearest look at Neptune's dusty rings in over 30 years. Modern tech is prying open a totally new window into how this giant operates.
And here's the ultimate takeaway, the real so what of this whole explainer. Neptune is no longer just the weird, windy outcast at the edge of town. As we've started mapping other stars, we've realized that Neptune-sized objects are actually incredibly abundant throughout our galaxy. Studying our own local ice giant, figuring out its supersonic winds, its dense fluid mantle, its hijacked moons, that gives us a vital blueprint for understanding literally thousands of mysterious exoplanets discovered light years away.
The crazy thing is, we've only ever briefly flown past Neptune once, way back in 1989. Think about everything we've managed to figure out from math, from Earth-based telescopes, and from that single quick flyby. So what other massive secrets about the birth of our solar system are still just sitting out there, hiding in Neptune's freezing depths? When humanity finally sends a dedicated modern mission back out to the edge, how will this invisible giant completely change our view of the universe all over again?